All right, kids, today we are doing average atomic mass. This is how we deal with isotopes and determining the mass that ultimately goes on the periodic table. And we're doing this kind of through an analogy. We're going to be looking at different types of an element we've created called M&Mium. So here's one cup, here's a different cup. You can tell these isotopes are bigger than those isotopes. And then it's not really M&Mium, it's called M&Mium, I think, that we're gonna add into this mix to give us our averages. So we're gonna go through the process of how we figure out and calculate this. Just a heads up though, unlike real atoms in a single isotope, so if this was carbon-12, every one of these would have the exact same mass. And if this was carbon-14, every single one of these would have the exact same mass as all the other carbon-14s. They're not. They're candy. Candy has some manufacturing defects. Too many layers of candy, bigger chunk of chocolate, different sized peanuts possibly. So we're gonna have to first cheat our way through to find the mass of each isotope, and we're gonna do an average, and we're gonna work through that one first. So I'm gonna be getting the masses for you guys on the balance in front, and Mr. Markey is going to be putting them up on the data table for us in the front of the room, and then we'll come back and kind of see what all we have. But we're going to go through and get each of these weights done. So we're going to weigh one plain M&M, and then we're going to weigh another one, and then a third, a fourth, and a fifth. And Mr. Markey is going to help you get all your data taken down. All right, so we're going to be weighing these. And first we're going to turn on the balance, and then I'm going to make sure it's in grams, G. I'm going to place a weigh boat. This is to keep my substance from contaminating the balance itself. But you'll notice the weigh boat does have some mass. So I'm going to hit this T button. It stands for tare. And what it does is it removes the weigh boat from the measurement. So we're starting out with the plain M&Ms, and we're going to weigh our first plain M&M right there. It's yellow. And it comes in at a whopping 0.96 grams. Gonna go ahead and remove that bad boy and place our next one in. This one happens to be blue, and it comes in at 0.86 grams. And we'll go orange this time. 0.86 grams, a little bit of consistency going on. Brown, 0.91, and our red one 0.82. So that's all of our plain M&Ms. Now we're going to change to our peanut M&Ms. And I'm going to keep the same weigh boat on there, and we're going to start out with yellow. Holy moly, 3.62 grams on the yellow one there. Our blue one, 3.15. This one's gonna be a little light. 2.51 for the orange guy. 3.08 on the red. And our green one comes in at 2.65. 2.65 on the green. Now we're going to the Skittleums. So let's take that out of there. Let's get our Skittles in there. That's the sour kind, my favorite. Actually, not really. Orange at 1.14. Purple, 1.12. Green, 1.10. Red, 1.07, and yellow, 1.13. So we've got all our masses now for each of our candies. Let's see what this is gonna look like.
Okay, so now that we have all of our information, now it's time to find the average mass of each of our isotopes. And remember, we're finding the average mass because of the inconsistencies within our individual candies. If we were just using regular isotopes, we would just use the mass of those isotopes. But, so since we need to find the average, okay, finding the average of anything, what you're going to need to do is you're going to need to add up all of those individual masses for a total of all of them. And then to find the average, since we have 5 samples, we are going to divide by 5. Okay? So you're going to do the same thing for plain, same thing for peanut, same thing for our Skittles, divide them all by 5 and find the average. Once we've found the average mass of each of our different types of isotopes, the next part is we're going to have to figure out percent abundance. And if you remember, anytime we do a percent is always a part divided by whole. In this case, we're talking quantity. And the part is going to be one of our isotopes. The plane, how many planes do we totally have over the total number of M&Mium candies, or M&Mium atoms, if you will. Okay? And in order to find our percent abundance, there's a formula. Okay? Percent abundance is going to be the number of plane divided by the total number of M&Ms that you are going to be counting in a moment, then multiply by 100. The percent abundance for peanut, how many peanut M&Ms do we have, divided by the total number of M&Ms times 100. And again, the number of Skittles divided by the total number of pieces of candy that we have divided by 100. And each of these is going to give us our percent abundance that we are now going to plug into an equation to help us find the overall average atomic mass. Okay, so what we have here is the total sample size of all of our plain M&Mium isotope. And what you're going to have to do right now is you're going to have to pause the video and you're going to have to count the total number of plain M&Miums we have. So go ahead and hit pause and count. Okay, so now once you've counted all the plain, now here are all of our peanut M&Mium isotopes. So what you're going to have to do now is hit pause and count the total number of peanut M&Miums we have. Okay, and finally we have our sour Skittles M&Mium. So now again, for the third time, you're going to have to pause the video and count the total number of sour Skittles that we have in our sample. Okay, so now that you have paused the video 3 different times and you've counted the total number of plain M&Mium isotopes we have, the total number of peanut M&Mium isotopes we have, and the total number of sour Skittles M&Mium isotopes we have, you should be able to figure out the total number of M&Ms. Add, okay? And then you know how many we have of each one. So what you're going to do is on your lab, and don't forget to show your work, and when you show your work, write out the formula, and then plug in the numbers, do your math, and figure out the percent abundance for plain, the percent abundance for peanut, and the percent abundance for Skittles. Don't forget, show your work. Okay, so now we're going to take the information that we have gathered, the atomic mass of each of our isotopes and the percent abundance of each of our isotopes, and we're going to plug them in to our average atomic mass equation. And our average atomic mass equation takes our 3 different isotopes, and it takes the percent abundance of our plain peanut, or our plain M&M, multiply that by the average mass of our plain M&M, add that to our percent abundance of our peanut M&M, which is multiplied by the atomic mass of our peanut isotope, and then that gets added to the percent abundance of our Skittle M&M, which is multiplied by the atomic mass of our Skittle isotope. When you take all these, multiply them and add them up, divide by 100, that will give us the average atomic mass of our M&Mium element.
All right, so one of the things we did when we did this experiment was we weighed each candy and then found the average weight of 5 of them to use as our atomic mass of each isotope. You saw the variation in each of those candies. There was a pretty big range, and so that inherently creates an error. Error is really important in science because we've got to be able to describe it, and one of your favorite answers as students for some reason is, I did my calculations wrong. Rule number 1, calculations can never be your error because you can always redo the math. So we're going to look at the error in this experiment. We have our balance here again, and I'm going to this time place an empty cup on there and go ahead and tear that out. And I'm going to pour all of our candy into the cup. And that is the weight of all of our candies. And hopefully you have your candies counted out. That's how we got our percent abundance. And you can see that the entire cup weighs 136.76 grams. And we're going to need that information to answer the percent error question at the end of the lab. So you have this value here, and we can find the average weight of our candy for real by dividing by all of our candies. This will be our accepted value, and the value you found by taking the averages and doing all your math is your experimental value. And we're going to work on finding our error on this lab. Good luck, guys.